that case will be that why use Python for machine learning in the first place. And as you can see, the main reasons for that is that it is the most popular language for machine learning. Pretty much every machine learning library that you can think of, be it PyTorch, TensorFlow, Keras, JAX, they all have Python APIs. Python also has a lot of data science packages like pandas, scikit-learn, which is also machine learning package in a sense, um, and a few others. So it's very easy to do the data science and machine learning with Python. Uh, and we are all in the HPC consulting team very familiar with Python, so it's easy for us to troubleshoot. So if you're using our clusters, it is much easier for us to troubleshoot problems with Python than it might be for any other esoteric language that you might want to use. So Python is a good choice for machine learning, but there are a few things that you might want to look out for when you are using Python. And the most common problems that arise are that people mix different Python versions, or people use different Python virtual environments, and I'll go into that a little bit later. But these are some of the common problems that we see. So be careful with that when you are using Python, that don't mix up all these virtual environments or versions. If you're using GPUs, then you might have to use some extra configuration in your code, because uh, Python by itself is not, or by default, is not configured to take advantage of GPUs. So you need to uh, do that manually in a sense. And there are a lot of package managers that you can use with Python. Pip is the one that comes built in with Python. There are others like Conda. Not all of them always work very well on HPC environments. So for this demonstration, for at least for today, we will just stick to pip and not use Conda or something else, because pip works very well on our cluster, so we'll go with that. But if you want to use other package managers, you can. You might just have to do some things a little bit non-trivially. All right, so let's figure out how to set up Python for machine learning on our clusters. So if you go through our docs, and if you check the link that is shared, there are links to how you can install packages, Python packages on our clusters. So for today, we'll be using mainly three packages. One is Torch, Torch Vision, and Fast AI. So Torch is the actual package name of PyTorch, and if you've used something like NumPy, then you can think of Torch as a type of NumPy that can run on a GPU. That's basically what PyTorch mostly does. Now, Torch Vision is a library built on top of PyTorch, which adds support for computer vision problems. Like you can use, with Torch Vision, you can do machine learning with images or even videos. And then there's Fast AI, which is strictly not necessary when you're coding with PyTorch, but I think like for the first example or so, it is a simple package to take care of a bunch of things. So sometimes it's a nice package to use. Though if you're doing something really complicated, you might want to write the code directly in PyTorch than using Fast AI. You have to make that decision based on your problem. But the kind of work I'm going to demonstrate today for that fast AI is a nice tool. So we will install all these packages in a Python version 3.8 virtual environment, and then we'll create a Jupyter kernel so that we can access those uh, from a Jupyter notebook. Okay, now to install the Python, now to create a Python virtual environment and install the packages. These are the commands that you need to run. They're also mentioned in more details in our docs, but for now, it's enough to know what these commands do. So before you can run this command, you have to start an interactive session. So if you have not done that before, let me demonstrate how you can do this. So at first, let's go to od.hpc.arizona.edu. Let me actually type that in the chat. So okay, so if you go to that link and after you log in, you will come to a page like this. It is the open on demand interface, and from here we can launch a terminal in which we can install those packages. So let's go to clusters, and under that you will see shell access. So if you click that, it will open this terminal in a browser, and if you're not familiar with terminals, it's an easy way to get into it. Um, so we have three clusters. Puma is the most advanced one. So and that's why it's kind of difficult to get time on Puma. So for now, to install the packages, we'll go to Elgato and we'll start an interactive session. So you can do that with interactive and then your group name, -a and group name, and that will start the session. And now you can load a Python module. So let's load module load Python 3.8. And after you load the module, you can create a virtual environment. So to do that, just run Python 3 -m when, and it doesn't really matter what name you give the virtual environment, but you need to know what the name is. So let's just, for now, I'll just give the name as Ven 38. So after a time, it will create the virtual environment, and then you can install the packages in that. So okay, now that it has created the virtual environment. If you go back, you can see that you also need to load this CUDA modules. That's because if you don't have them, then PyTorch will not be able to take advantage of the GPUs. So oh, so it is there are 3 CUDA modules, and you can load all of them, and then and after that we need to activate the virtual environment. So just do source, and it was ven38. So ven38 bin Python, sorry, bin activate. And then you can install your packages. So for PyTorch, if you check the PyTorch website, it will tell you that you need to run this command to install PyTorch. So we'll just directly run that command and you can see that here it says CU118, so it means that it is downloading the version of PyTorch that is compatible with the CUDA module that we just loaded. Okay, so if you want, you can try this steps as I'm showing them. That might help you to remember the steps or get used to them. And while we're waiting for this, feel free to ask any questions. You don't need to wait till the end of the. Are you not seeing my screen, or are you just seeing me? Uh, okay, let me try resharing my screen again. Are you seeing this now? Okay. Sorry about that. I was not sure that you are not. I didn't know that you're not seeing it. Well, hopefully, you're still able to follow whatever I said. In case you're not in, you missed something, feel free to ask me. Also, I'm not always looking at the chat, so if you want to just turn on your mic and ask, you can do that too. Okay, so yeah, it will take a little bit time to install once it downloads the packages. Okay, yeah, I can show uh, how we came to the terminal again. So let's go to o- open on demand, and I have shared the link in the chat, but I can just share that again. So So let me just share the link again in the chat. So that's where you go. And then if you after you log in, it will take you to a page like this. And then if you click clusters and shell access, then it will take you to the terminal. Okay, so if you just do that here, you'll get it. All right. So while we are waiting for that to install, it should finish in the next couple of minutes, hopefully. You'll also see that we need to install the fast AI package, and then we have to install Jupyter because we would like to use Jupyter for some of the problems. If time permits, I'll try to show how we can do machine learning without using Jupyter because that's important when you are dealing with large models or large training time. It might be better to not use Jupyter because then it'll be easier to debug or your code or to see how much time or memory it actually takes. Uh, but for now, we'll first stick to Jupyter and then go to the non-Jupyter part because that's a little bit more complicated than this. Um, Okay, so now that it's installed Torch, let's just install Fast AI, and that should be faster. And yeah, like I was saying earlier, don't mix different Python package managers. So right now, as you can see, I'm only using pip. If you're used to using Conda or something, that's fine. But try not to mix different virtual environments. Like you can use Conda and pip together, but definitely don't mix the two virtual environments. And then after that, we'll just do the Jupyter. And are there any questions yet, other than the ones that were there? Okay. If there are no questions yet, let's just see how we can use Jupyter on open on demand while you are waiting for the packages to install. So to use Jupyter, we again go to open on demand, and then we go to this tab called interactive apps. And underneath that, you will find this option Jupyter Notebook. So if you click that, it will take you to this form that you need to fill. So this form already has the values that I had used just before I started this workshop, so that I can have a Jupyter notebook in time, because sometimes it takes time for the system to prepare a notebook for you, depending on the amount of people are waiting in the queue for that. So it can take some time. So the first thing you have to choose here is the cluster that you would like to use. Now the top two, they have GPUs, and Elgato does not have any GPUs. So since the wait times on Puma is much larger, I just chose the second one. Um, but when you are doing your actual machine learning jobs, if you need, you can choose Puma, of course, but this is just for this demonstration here. I'm not choosing that. And then you can choose the runtime. That's the amount of time that you are that the notebook will be active for. So here I've just given a single hour, but if you need, you can give more. The code count tells you the number of CPUs available, and each CPU comes with some amount of memory. So for 6, this will be 6 times that much memory. So Ocelote has 6 GB of memory per CPU. So which means if I choose 6 CPUs, it will give me a total of 36 GB of memory. Okay, so if you see that your job is needing more memory, you can increase the number of CPUs to have access to more memory. And then after that, if you need a GPU, you can choose that. If you don't need a GPU, you can just choose no GPU. For now, I'm going to choose that we'll use a GPU. And then after that, if you give your group name and then you choose a queue, so it's best to choose a standard over there. And once you have done all of that, just click launch, and you see it will be queued here. And once the system has all those memory and CPU that you had asked for, it will create the notebook for you. So I had done that already. So that's why there is a notebook over here, which you can, which was prepared for me already, and I can connect with that. Yes, we'll make the recording available, but if you'd like to see the actual material that's there in the docs, so I can just share the link here in chat, and if you want, you can just follow it from there directly. Um, okay, so now let's see. So FastAI has been installed, and now we'll install a Jupyter. Um, and I think I have to use force reinstall there. Yeah. If you're getting any kind of error while trying to install FastAI, I'm not sure why you might be getting that, but we can look into it after this session. It's okay if you're not able to run the code right now. You can just see whatever I'm doing, because and the code is available to you, so you can run that afterwards, and we can figure out what is going wrong. Um, do we have to recreate the Python virtual environment every time? You don't need to recreate the virtual environment every time, but you need to activate that every time you want to use the packages that are installed in it. Okay, so whenever you want to use the packages, you need to activate that. For Jupyter, we'll make a Jupyter kernel, so that you can directly use the kernel, and that way you don't need to activate that all the time. Okay. This might take a little bit, but we can okay, we'll just wait for this to finish. During this time, if there are any questions, feel free to ask me, because I think it's important to see how the kernel is created and how we actually use that. Uh, so we'll just wait for that for a bit. So as you can see in the error message, in the messages that we are getting when this is being installed, that there were packages that were installed earlier and can now being uninstalled and being installed again. This is because there are probably some kind of version conflict. So this is something that you need to be careful when using Python, that version conflicts can happen. So you need to be sure that you're using the correct version of packages. Yes, the virtual environments will consume storage in the user's home, but you can store the virtual environment at a different place. And I think we have got some details on that in our docs. But we can talk about that afterwards if you need. But yeah, it will take space. Okay, so now that Jupyter has been installed, we can create the kernel. So it will use this command ipython kernel install, and let's just copy and paste. Oh, paste. Okay, so first need to give this a name. So let's give it the name workshop 538. That's because I have tons of Py3 kernels, so just not to mix all of them. And then this part is kind of optional. You don't need to have a display name, but if you like, just because it is easier to figure out what it is, you can do that. So let's say I give the name Python 3.8. workshop. Okay, so now the kernel has been installed. So now I can use that in my Jupyter notebook. So let's connect to one of them. Okay, and I have my notebooks in workshop, yeah. And let's see, let's go to Python and we'll check the first one, the fungi. So open the fungi classification notebook, and it is there in the link that I have shared. So if you want, you can download that from the link. Okay, so this was already made with a different kernel, which was named Torch Py38, which has got the same packages. But if you want, you can change the kernel to the one I just made, and I can just do it like Python 3.8 workshop, and it will just go to that kernel. So are there any questions on using kernels for Jupyter? Okay. All right. If there are no kernels, if there are no questions for using kernel Jupyter, let's go through this notebook. But before I go through it, let's just get an idea of what you are actually what is the problem that we are dealing with in this example. So this is a data of fungi images. And if you check the link that I shared of the from our docs, you will see that uh, all this data is in this location called contrib. So I'll just copy this location in the chat, uh, and you can access this from an interactive session, and you can copy it to your directory wherever you'd like to keep that. And after you've done it, you can then run the commands in the notebook. Okay, but if you don't want to do it now, it's fine. You can just follow me. You can do it afterwards too, if you'd like to. So what we are trying to do here is we are trying to figure out the species of the fungi based on the images. So these images, they come with a fungi image and the name of the species, and we're trying to train the model on that. So in the future, if you give it some image of a fungi, it can tell you which species that fungi is from. Okay, so I have actually already kept all the data in my path. So I can just run the code directly. But if you would like to do it yourself, then you need to get the data from the link that I shared, and then keep it in your path so that you can run the commands in the notebook. Okay, so let's run them. And so first we import the path function from the pathlib library, and then we give it the path. Okay, don't have it. Let's see where it. Oh, okay. There's a Python in there. Forgot about the Python. Okay, now it should run. Oh, even not running now. All right, this is why I should run things before 220. Oh, okay, okay, yeah, because it is right beside, I mean, the notebook and the uh, images were right beside in the same folder. That's why it is not taking the path earlier. But now that I've given it, you can see that it is not accepting the path. So this is just a function to tell you what are the um, folders in a particular subfolder. So when I run that, I see that my training folder has all these subfolders, and from this you can see that these are the scientific names of the fungi species. Okay, so this is what we're trying to find out. That we're trying to figure out the name of the fungi species from the image. So, and we do the same thing with the test, and we confirm that they both have the same species. And if you check any of those subfolders, you can see the kind of things they contain. So each of them contains just a bunch of images. They're all named some random numbers, uh, and but they're all just images that you can see from this JPG file name. And if you want to see the number of images, it tells you that there are two with around 1,000 and two with about 800 images. Okay, and we can see what they look like. So if you run this code, it will produce this table of images for each of those species. Now, let's first try a much simpler problem. So instead of trying to classify all four, we'll just try to classify th these two. Okay, so the bulleters and the ammonita, because they have the similar number of images. So we'll just try to classify those two. So this is a function that I have made to copy those particular images to another subfolder called binary. But I have done that already, so I'm not going to run that now. But when you are doing this, if you'd like, you should run this code. Okay, and now we can look with how you can use fast AI to train that. So first we import the first AI libraries, and that is just importing first AI.data.all. And okay, I see you. Okay, so you are seeing this error, and this happened because I did not include this option, the system site packages, when I made the virtual environment. So if you have done the same thing as I did, when you run the code, you will see the exact same error. So the way to solve it is to recreate the virtual environment, but now with this system side packages. Okay, because if you don't run that, it will not be able to uh, import the fast AI libraries. Any questions on that? Okay, so if you're doing this, then the your best option is to just recreate the virtual environment, but definitely make sure that you are actually using this option called system side packages when you make that, so that it will have access to that particular library that FastAI needs. For me over here, since I do actually have multiple kernels, I can just shift to another kernel, which I think has it, but maybe we'll see that it does not. But I don't want to. Let's see if it actually works. Um, Very fast I work with this. Okay. Okay, yeah. So fast AI was imported with that particular with kernel. So that's fine. But now whenever you change kernels, you need to again run these things because uh, it has now been restarted. So okay, and now after importing fast AI, you need to create a set of data on which you will train the model. So here, this line, the D block is just doing that. And you can see the number of images in the train set and the test set. So, so we are going to train the model with the train set and then test it with the test set. Like we're going to see if it's performing the way we expect it to. Okay, and you can see that that your data set knows that these are the two labels of the images that's there uh, in those folders. And this is just, if you do this, if you run the TLS show batch, it will just show you a batch of images from the just a um, random batch of images. Okay, so now we actually, so this is the line where we actually get the model. So we are going to use a model called ResNet 34. This is a model which has been pre-trained on a different set of data, so it already knows some things about shapes and colors and everything. So we're just going to take that pre-trained model and then just fine-tune that to this particular data set, so that now we can use it for this. Okay, so just to vision learner data set, and then we need to first find out a learning rate. So with this function, LR find, you can find a easy learning rate uh, for your model, and it will just do some kind of dry run uh, for a bit, and then tell you a suitable learning rate for that. So this is now running on the GPU. So the good thing with fast AI is that if you have a GPU available, it will automatically choose that. If you're writing the code in PyTorch directly, then you need to tell it, the PyTorch to choose the GPU because PyTorch will not do it by default. And if you have to run this on the CPU, it will take much longer than it is doing now. Yes, there is a way to access it into the node to check with for which the GPU is being used. I'm not sure if can figure out which node the Jupyter notebook is using directly, but if you're doing things uh from the terminal, then that is pretty easy to check. Anyway, so now it gives you this learning rate, and you can use a number somewhere in that somewhere near this point. But if you want, you can choose some other value too. That is just expected to be a good learning rate. Okay, so now that's what we'll do, is that we'll fine tune this model for 3 epochs, and you can see that the error rate will decrease a lot within just with that. So this first the first epoch that you see, this is not an actual training epoch. It is just fitting the model to the data, in the sense that this model was trained on a different set of data, which had like 1,000 classes, whereas this has got only 2. So the first epoch is trying to fix all those details, and the next 3 epochs are the actual training epochs. So now you can see that these are your actual training epochs, and you can see that the train loss decreased a lot in just 3 epochs. Though we are not mainly concerned with the train loss, we are more concerned with the error rate, and that's not large. That is not large to begin with, and then but here you can see it's quite less. No, the final learning rate function does not change the learning rate. It just tells you which learning rate will be a good choice. You don't I mean, you don't need to pick the rate that is there. You can choose a different rate if you'd like. That you can see that I didn't choose that exact number, but something near that. So it's up to you what number you choose, but that's just a way to find out which number might be a good choice. And this model is not exactly in the package, but the package will download that for you if you just give the name. So there are other names, like you could have given Resident 18 or ConvNet Tiny or something like that, and it would just download those model for you. And once you have done the training, you can see how well it is performing. So this option, the show results, just gives like a random collection of images, and it tells you that, as you can see, for all these images, the actual label and the label that the model gave are the same. So it did a pretty good job on this random batch. And then if you'd like to see how well it's actually performing, the best is to do this interpretation, and it will show you, it will give you some idea of if which part is not learning well and which is learning well, in a sense. So let's just look at this confusion metrics. We don't have enough time to go through all of that. And you can see that it is giving the correct answer for all the images in the test set except for like 10 of them. So it did a pretty good job of learning the images. Okay, so are there any questions on any of this that I just demonstrated? I mean, fast AI is not necessarily something that you need to learn. This is just a way to show to do this problems pretty easily. So if you're doing some kind of transfer learning, like I did here, that I took a model that was trained on a different data and then use that for this. For problems like this, Fast AI is a good tool because you don't need to write a bunch of code. But if you're doing something more complicated where you are building the model uh, uh, and you're also building the data and everything, then you might need to use PyTorch directly. So FastAI is just a library on top of PyTorch. It is using PyTorch in the backend. So if you need, you can go into PyTorch directly. Okay, so that was just binary, and it's the same thing if you want to do it for the for all the 4 species. I'm not going to do it now, but it's the exact same code, and this is what I've done previously, and you can see that even with all 4, it does a really good job of learning it. In the last 10 minutes, if there are questions, I can answer those, or there is a different example that I can show. So if there are questions, please ask. If not, I will just show a different example. Okay, not hearing any questions. So let's check out the other example. And this, I will not use Jupyter for this. Where did it go? Okay, where is my open on demand? Okay, yeah. So here on open on demand, if you can, there's something called a file browser, and that is under files. And I just want to show you how you might be able to do something from uh, the batch jobs. And this is something you'll probably learn a little bit more tomorrow if you come to the parallel workshop. But I'll just still just show some example on that. So here I have a code which is going to run PyTorch on multiple GPUs. And this is using something called the distributed data parallel, which is there in the PyTorch nn.parallel libraries. You can just import that from torch nn.parallel. And the main thing over here is that you need to, so what distributed data parallel does is that it copies your model to multiple GPUs and then divides your data into multiple parts, and each copy of the model is trained on a particular part of the data, and then they're all combined together for the final answer. And I mean, you can go through this code afterwards, but the main part that you need to notice here is that to use this thing, you first need to wrap your model with this distributed data parallel, which I do in this line. And the second thing that you need to be careful is that when you are training your model, you need to, before each training epoch, you need to do this. The self.train data.sampler.set epoch. That is something you need to run. So this and these are the most important thing when you are running distributed data parallel. And then the other function here is that define the EDP setup. So this function will tell PyTorch that there are multiple GPUs effectively, and which GPU it should use for each particular copy in a sense. So this is your Python code. Now to actually run this code, what we need is called a batch script, and which is this. So this you will learn tomorrow a little in more details. But the main thing that you need to be you need to know here is when you're writing your bash script, you first need to tell the like for the Jupyter notebook, we have chosen standard as the partition, and then your PI's name and the time, and you do all the same things here. But then when you're trying to do multiple GPUs, what I'm doing here is that I'm telling it that there are two nodes with this line, and each node has access to a single GPU. So in total, there are two GPUs. Okay, and then this part here just finds out the IP address of those GPUs, and then it will send that to this function called torch run, which is a part of PyTorch, and then torch run will be able to run this Python file that we had made earlier with on multiple GPUs. So to actually run this example, you need to do you again need to go back to the terminal. That was over here, and now let's actually go to Ocelote. So we don't need to be in an interactive session anymore. I go to Ocelote, and then I'll have to go to the location where I have the files. So let's see. Why it's not going? Oh, sorry. It's putting too many formulas. Okay, and go to Python, and there you have multi GPU. Okay, so now if you see there is the multi GPU dot underscore dot run dot py. That's the Python file. Multi GPU dot slurm is your batch file, and this datautils.py is just a file that the multi GPU torchRun.py file imports something from that. Now to actually run that code, we can just do sbatch multi GPU dot slurm, and it will submit a batch job for you, and you can check on and you can see that it has submitted a job for me on two nodes, and right now it is pending because those nodes are probably not available right now, but after they're after they become available, it will run that file and it will produce the output. So this is kind of more involved than using Jupyter. But I wanted to show this because when you're doing really large machine learning jobs, then it is easier. That is much better to use batch jobs than with Jupyter. So um, if you're not if this is not something that that you are very familiar with, you might. I mean, it is a good idea to learn how to use batch jobs. Example of same workflow with PyTorch. I don't have that right now, but I can prepare that afterwards if you'd like that. I mean, it's not too difficult to do the same thing with PyTorch. But you'll have to write a little bit more code with PyTorch. With Fast AI, it's much simpler. But yeah, I can write some code with PyTorch and add that to it. So the part that I just showed now with the batch job is not there in the docs site yet, but I will add that hopefully by this week, so you can take a look at that towards the end of the week. Are there any questions on this? We are towards the end now. We actually reached the time, but if there are questions, I can take those. Then we can go. And if you'd like to ask them, you can unmute yourself and ask. You don't need to type if you don't want. I do suggest that you can come for the parallel workshop that is there tomorrow, so that you will get a better idea of the bad jobs that I just talked about. Okay, I guess if there are no questions, we can end this here. Thanks for being here. See you all tomorrow. Yes. Bye.